So in this video, I'm going to talk about trying to use the Taylor and Maclaurin series to try to figure out what this indefinite integral is, which is the indefinite integral of arctangent or inverse tangent of x squared dx. Now, this is not a easy integral to find in a normal situation. However, using the Taylor and Maclaurin series, we can kind of figure this out a little bit easier. So it's important to pay attention to the fact that arctangent or tan inverse of x can be written as x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7. And it kind of keeps going until we talk about the general term, the nth term, as negative 1 to the n times x to the 2n plus 1 over 2n plus 1. So you could also write this kind of as the series, the summation notation of n equals 0 to infinity of negative 1 to the n of x to the 2n plus 1 over 2n plus 1. Again, notice that if you plug in 0, you get, of course, a positive number here first, positive 1. This becomes x to the first here over 1. So now that I've got this written kind of in summation notation, I do want to update it a little bit so that it has this x squared in it. So I'm going to rewrite it as tan inverse of x squared. And what that means is I'm just going to kind of plug in x squared where there was an x before. So this first one will be x squared minus x squared to the third over 3 plus x squared to the 5th over 5 minus x squared to the 7th over 7. And so hopefully you're picking up on the fact that what that means to the general term, to the summation formula, is it's still going to be negative 1 to the n. It's just going to change x squared to the 2n plus 1 over 2n plus 1. And I can kind of update that by combining the exponents. And so I'll rewrite the summation notation as negative 1 to the n. And again, I'm just going to combine this and make it x to the 4n plus 2 all over 2n plus 1. Now that I've got that covered, I want to go into the idea of integrating this. So that was kind of the express purpose, is we have to do an indefinite integral. So what I'm going to do is just think about how I would integrate each individual term and how that would change the problem itself. So for example, if I integrate this x squared, that's going to turn into 1/3 x cubed. If I do the next one, which was x to the 6th, that's going to become minus x to the 7th over 21, because we've got a 3 at the bottom already. This is x to the 10th, so it'll become x to the 11th over 55. And hopefully you guys are getting the idea on how this is going to work. Basically, we are adding 1 to the exponent. So if I think about my general term, we're still going to have that negative 1 to the n. That's not changing. But I'm going to end up having x to the 4n plus 3. My exponents are going up by 1. And I'm going to divide by that new exponent, which is 4n plus 3 times 2n plus 1. So in total, the summation here will look like the sum from n equals 0 to infinity of negative 1 to the n of x to the 4n plus 3 all over 4n plus 3 times 2n plus 1. And you can simplify that denominator if you really wanted to, but I'm just going to be fine leaving it alone. And that is my final answer. Hopefully this helps you guys. Let me know if you have any questions. If not, have a great day. Bye.